A very good morning to everyone. Today's topic is about IUPAC nomenclature of organic compounds, presenting by Ms. Neelambari, Assistant Professor, Faculty of Pharmacy, Dr. MGR Educational and Research Institute. And the contents of the topic are introduction, basic structure of IUPAC name, IUPAC rules for naming compounds, exercise, and reference. Introduction. What is IUPAC? IUPAC nomenclature is a systematic method of naming organic compounds according to the rules, internationally accepted rules established by the International Union of Pure and Applied Chemistry. And the objectives of the IUPAC nomenclature is to assign a unique name to every compound, indicate molecular structure through the name, and ensure uniformity in chemical communication to eliminate ambiguity in naming. And basic structure of IUPAC name. The basic structure of IUPAC name is divided into three parts: prefix, root word, and suffix. The prefix and suffix is further classified into two types: primary and secondary. We'll see one by one. What is meant by secondary prefix? The secondary prefix identifies the substituents or the side chain branches attached to the main carbon chain. For example, alkyl, ethyl, methyl, chloro, bromo, these are the substituents attached to the main chain. That is your parent chain. Whereas the primary prefix distinguishes between the open chain and a closed chain molecule. If you are naming a closed chain molecule, then you should add a prefix cyclo to it. And what is meant by root word, which indicates the number of carbon atoms present in a longest continuous chain. The longest continuous chain is otherwise called as a parent chain. If 5 carbon atom is present in your parent chain, then the root word is pent. If 3 carbon atoms present in your parent chain, then the root word is prop. What is meant by primary suffix, which indicates the type of carbon-carbon atoms, that is your saturation part. If single carbon atom is present, then it is known as alkane. If double bond is present, then it is known as alkene. If triple bond is present, then it is known as alkyne. Then what is meant by secondary suffix? The secondary suffix majorly identifies the primary functional group present in the molecule. For example, alcohol, aldehyde, ketone, carboxylic acid, etc. Now, here is the pictorial representation for the better understanding of what is meant by root word, what is prefix, and what is suffix. Look into it. The prefix, the root word, if one carbon is present, then it is known as meth. If two carbon is present, then the root word is eth. If carbon is 3, prop. 4, but. 5, pent. 6, hex. 7, hept. 8, oct. 9, non. 10, and dec. Prefix, which indicates the substituents. X, halo. Halo represents the chloro, bromo, fluoro, iodo, everything. And CH3 is methyl, and CH2, CH3 is ethyl. These are the substituents attached to the parent chain. And primary suffix, which indicates the saturation part: single bond, double bond, and triple bond: alkane, alkene, and alkyne. And secondary suffix, which indicates the primary functional group present in a molecule: alcohol, acetamides, aldehydes, ester, ketone, nitriles, carboxylic acid, acid chlorides, and amides. These are the suffix we should use. If a carboxylic acid is the major functional group present in a molecule, then the suffix should be oic acid. We should not use a carboxylic acid. We should use oic acid. If alcohol is the primary functional group present, the suffix should be OL. If aldehyde is the primary suffix, if aldehyde is the primary functional group, then the secondary suffix is AL. If ketone is the primary functional group, then your suffix is ONE. Now moving into the IUPAC rules for naming compounds: alkane, only alkane. Now next we'll see alkene and alkyne. And the rules are: rule number 1, select the longest continuous carbon chain, which is known as the parent chain. Rule number 2, select the longest chain. Rule number 3, number the longest chain from one end, which gives the lowest value to the carbon carrying substituents. Note the word, we should give the lowest value to the carbons carrying substituents. So here is the carbon carrying substituent 1, 2, 3, 4, which is the longest chain. So we have selected the longest chain. Number the chain from one end where the carbon carrying substituent should carry the lowest numbering. So 1, 2, 3, 4. 2 is the lowest number. So look into here 1, 2, 3, 4. The carbon carrying substituents which carries the position number 3. So which is the lowest number, 2 or 3? 2 is the lowest number. So this kind of numbering is correct and this kind of numbering is wrong. So 1, 2, 3, 4. The numbering is right. Now moving into the fourth rule. Three rules now we have completed. Now moving into the fourth rule. What is the fourth rule? Identify and name the substituent by indicating its procedure. So look into the example. We have named the compound, we have numbered the compound, we have selected the longest chain, and the root word is but because 4 carbon atom is present. So the root word is but. And what about the saturation? Single bond. So it is ane, alkane. So butane. Okay. Now look into the substituent. Identify and name the substituent by indicating its procedure. What is the substituent present here? Methyl group. So we have identified the substituent and we also named the substituent. Now mention its position. So in second position, methyl group is present, which is your substituent. So how we should name it? In second position, methyl group is present and your root word is but and your saturation is ane. So 2-methyl butane. So look into the explanation. Position number 2. Position of the alkyl group. Its alkyl group is nothing but your substituent. Methyl is your substituent present in the position number 2 attached to the alkyl group. And butane is the longest chain. This is the one example for your alkane compounds. Look into the few more examples. Rule number 6. Identify the substituents by the name and position number. Here is the longest chain. 5 carbon atoms present in a parent chain. So the root word is pent and the saturation part is ane. All are single bonds. So pentane. Now look into the substituents. What are the substituents present? Name the substituents by indicating its positions. Okay. So two substituents are present and the two substituents are methyl groups. Two or methyl groups. So note down the position number 2 and position number 4. So how we can name here? 2, 4 dimethyl pentane. Now look into this. In third position, 2 methyl groups are present. Now how will you name here? 3, 3 dimethyl pentane. So here is somewhat critical rule. When two or more substituents are present, and how will you name them? We should name it in an alphabetical order. So here is a 8 carbon atom present in a parent chain. So what is the root word? Decode the root word. If 8 carbon atom is present, then the root word is oct. So the root word is completed. Now focus into the suffix. Is there any functional group present? No. So that part is eliminated. Now moving into the saturation part. What is the saturation here? All are single bonds. So the saturation is ane. So octane. So your root word and the suffix part is completed. Now focus on to the prefix part. What is the prefix part? Cyclocompound. If any cyclocompound is present, then we should add the word cyclo. If not, focus into the what are the substituents present and what is the substituent present and in what position it is present. We should focus on it. So now focus on what are the substituents present. In third position, methyl group is present. In fifth position, ethyl group is present. Then how will you name here? 3 methyl, 5 ethyl, octane. Am I right? No. The rule is when two or more substituents are present, their names should be arranged in an alphabetical order. Ethyl and methyl. E for ethyl, M for methyl. Which comes first in an alphabetical order? The letter E comes first. Later the M comes. So how we should name here is the ethyl should come first, next the methyl. So in ethyl, where the ethyl is present? In fifth position. Irrespective of the position, the ethyl should come first. So 5 ethyl, 3 methyl octane. This is the rule you should never forget. Now, going into the IUPAC rules for naming compounds. Alkene. Now we have completed alkane. Now stepping into the alkene. The first few rules are similar. First rule, select the longest chain, name the longest chain, number the longest chain from the one end where your double bond should get the lowest number. So here is the example. 4 carbon is present. What is the root word if 4 carbon is present? But. So next rule, number the carbon chain as your double bond should get the lowest number. So here the double bond is present. So where should I start my numbering? Either from left to right or right to left. The double bond should get the lowest number. So I should start my numbering from here. So 1, 2, 3, 4. So the double bond gets the lowest number as 1. So butene. In first position, the ene is present. So 1 butene. Moving into the next rule. Let us see about the next rule. Alkane groups and other substituents are numbered, placed as prefix in the alphabetical order. So 5. The parent chain contains the 5 carbon atoms. So the root word is pent. Focus on the suffix. If any functional group is present, no. Cancel it. Now come into the saturation part. What is the saturation part is here? Double bond is present. In which position it is present? Position number 2. So pent 2 ene. The root word and the suffix part is completed. Now focus on to the prefix. What is the substituents present? Methyl group is present. In what position it is present? And fourth position it is present. So 4 methyl pent 2 ene. This is the way of naming an alkene compound. Now coming into the sixth rule, if two alkene groups or if two double bonds are present in a single compound, then we can name it as an alkadienes. Look here, 4 carbon atom is present. So the root word is but. 1, 2, 3, 4. In first position and in the third position, a double bond is present. So 1, 3 butadiene. If two double bonds are present, then we can name it as a alkadienes. So we can name here as 1, 3 butadiene. Now, IUPAC rules for naming compounds. Alkyne. We have seen about alkane, alkene. Now moving into alkyne. First three rules are similar. Select the longest continuous chain, name the longest chain, and number the longest chain from the one end where your triple bond gets the lowest number. In alkene, what you have seen, the double bond should get the lowest number, whereas in alkyne, your triple bond should get the lowest number. And the alkyl groups and the other substituents present are numbered and placed in an alphabetical order. So look into the example. 6 carbon atoms are present. So what is your root word? Hex. And focus on to the suffix. Does any functional group is present? No. Kindly omit it. Now moving into the saturation part. Single bond, double bond or triple bond. What is present? Triple bond is present. And where it is present? In a second position. So hex 2. What is the saturation part? Alkyne. So YNE. Hex hyphen 2 hyphen YNE. So your root word and your suffix part is completed. Now focus on to the prefix part. What are the substituents present there? In which position it is present? My substituent is methyl. In which position it is present? Fifth position. So 5 methyl hex 2 YNE. And you should not name it as 2 methyl 4 hexane. Like that, you should not start your numbering from right to left. You should start your numbering from left to right. Why? Because your triple bond should get the lowest number. Now, IUPAC rules for naming alkyl halides. First rule, select the longest continuous chain, name the continuous chain, number the continuous chain. Other substituents are numbered, named, and placed as prefixes in alphabetical order. So look here, carbon chain. 3 carbon atoms are present. So your root word is pro. And what about the saturation? Single bonds. So propane. In which position the halide is present? Position number 2. Bromo is present. So what is the IUPAC name of this particular compound? 2-bromopropane. So look into this. 1, 2, 3, 4. 4 carbon atoms are present in your parent chain. In position 1, chloro is present. In position 2, methyl is present. So what you should follow here, when 2 or more substituents are present, the prefixes should arrange in an alphabetical order. So methyl should come first or chloro should come first. The chloro should come first because the C comes first. Okay. So 1 chloro, 2 methyl, butane. Saturation part is ane. Only single bond is present. Okay. IUPAC rules for naming a compound: alkane, alkene, and alkyne. If a single bond is present in a molecule, yeah, we can name it. If a double bond is present, yeah, we learn to name it. If a triple bond is present, we can name it. We have learned it. But my question is, if a single bond, a double bond, and triple bond, all the 3 bonds are present in a single molecule, do you know to name it? Come, let me learn about it. For rule number 1, select the longest continuous chain. Rule number 2, name and number the longest chain. Rule number 3, indicate the position of the double bond by the lowest number. While you're numbering the longest chain, keep it in a mind that the double bond should get the lowest number, because when double bond and triple bond both are present, your double bond has the highest priority over the triple bonds. If a compound contains single bond and double bond, where you will give the highest priority? For double bond. If single bond and triple bond is present, where will you give the highest priority? For triple bonds. But if a double bond and triple bond both are present, where will you give the highest priority? You should give the highest priority only to the double bonds. Your double bonds have the highest priority over the triple bonds while numbering. Other substituents are numbered, named, and placed as prefixes in alphabetical order as usual we do. So here is an example. You have a single bond, you have a double bond, and you have a triple bond. So where you'll start your numbering, from right to left or left to right? We should start our numbering from double bond. Where your double bond is present, there you should start your numbering. So here my double bond, so I start my numbering here. So 1, 2, 3, 4, 5. 5 carbon atoms are present. So what is the root word? Pent. In what position the double bond is present? First position. Pent 1 in ene, so en. In which position triple bond is present? 4. So 4 yne. So root word and the suffix part is completed. What about the prefix part? What does the prefix indicates? Substituents. Is there any substituents? No. So we don't want to worry about it. So we have completed the root word and we have completed the suffix part. So this is the name for this particular compound. Now here is the exercise for you. What we have learned so far: alkane, alkene, and alkyne. So here is an example. Kindly look into it and try to get your answer. I'll play with you. So 1, 2, 3, 4, 5, 6. 6 carbon atoms are present. So what is your root word? If 6 carbon atom is present, select your longest continuous chain. As this is my longest continuous chain, I have selected, and name the continuous chain. What is the name? If 6 carbon atoms is present, hex. The root word is hex. And what about the saturation? All are single bonds. So the saturation is ane, A-N-E. So hexane. So root word and my suffix part has been completed. Hexane. So look into the prefix part. Focus on the substituents. What are the substituents present and in what position it is present? So 1, 2, 3, 4, 5, 6. So in second position and the third position, ethyl group is present. So 2, 3 diethyl. In fifth position is methyl and hexane. 2, 3 diethyl and 5 methyl hexane is the correct answer. Try to solve one more exercise. So what is the root word and what is the continuous chain? Here the continuous chain is this one. 1, 2, 3, 4. 4 carbon atoms present. If 4 carbon atom is present, what is your root word? But. And what about the saturation? A double bond is present. So the saturation is butene, E-N-E. In what position the double bond is present? In first position, because we should give a lowest number to the double bond when it is present. So I should start my numbering from here. So 1, 2, 3 and 4. In third position, have a substituent. Two substituents are present and the both are methyl group. So 3, 3 dimethyl 1 butene. So option C is my answer. And these are the references which have referred the notes for IUPAC nomenclature of organic compounds. Thanks for listening. Thank you.